The final lesson for Unit 3 equations is Lesson 3.9. It's about special solutions and special cases when we solve equations. This is on Notes Packet, page 18. So what we've seen so far in this whole entire chapter is that every time that we've had an equation, we've ended up having one solution. What this is going to be called is that it means it has one answer. So when we isolate the variable, we get x equals, and then we have a number on the other side. These are what I would call the normal cases, because this is what we're most used to seeing. So for example, if I had a plus 3 is equal to 2a minus 4. So you would go ahead, you would move the a because it's the smaller variable. You would be left with 3 equals a minus 4. You would add 4 to both sides, and then when you get 7 is equal to a. So a is represented by only one number. So one number can take the place of a, and that's it. Another thing that can happen is when we have no solution. So I'm going to start off with our example here. So if we had 4a plus 7 is equal to 4a minus 3. We're going to go ahead. Notice that the a's are the same, so I'm just going to subtract from the left side. It doesn't really matter. And when I do this, I'm left with 7 is equal to, these cancel out as well, 7 is equal to negative 3. Well, that's not true. So we need to put a slash to that equal sign because 7 is not equal to negative 3. So what ends up happening in this scenario is you get an equation or a solution that's not true. For example, 7 equals negative 3. The variables are all gone. So they've all canceled each other out. And that's what ends up happening. So then we call this, we would just write no solution, because it means no matter what number you put in for a, you're still not going to have an answer that's going to end up being equal on either side of your equation, on either side of your equal sign. The third and final thing that can happen is what we call infinite solutions. So what I'm going to do is, again, start off with an example. So if we have 2 parentheses a plus 4a plus 5, change this. 2 parentheses 4a plus 5 is equal to 5a plus 10 plus 3a. So this one's a little bit more complicated. We're going to distribute over here, so we'll get 8a plus 10. And over here, we're going to combine our like terms. 5a plus 3a is 8a. And then we have the constant plus 10. So you can actually stop here if you wanted to, because notice that both sides of your equal sign are equal. They're the exact same thing. So the results are equal. And you can also say that they match on either side of the equal sign. This is also a true statement, because if I went ahead and subtracted off the 8a, I would be left with 10 equals 10, and that is actually true. So in this case, we have what we call infinite solutions. And what happens here is that it doesn't matter what number we plug in for a, whether we plug in a fraction, a decimal, if we have a negative number or a positive number, or even if we plug in 0, it's not going to matter. Any single one of those are going to work for a. So what we're left with is any solution. An infinite number of solutions can happen. So down at the bottom here, we have a couple examples. We're going to label these as one solution, no solution, or infinite solutions. So in example number 1, we're going to go ahead and start to solve. Over here, there's nothing to do, but on the right side, I do see I need to combine some like terms. And on the left side, 3y minus 5. So I'm noticing things don't look the same here. 3y's, I'm going to subtract 3y on both sides. And I'm left with negative 5 equals negative 9 because those cancel. That is not a true statement. So because it's not true, that means there is no solution for this problem. In example number 2, left side looks good, so I'm going to leave it. And on the right side, I'm going to distribute, and I get 2y plus 4. Do you notice that both sides of the equal sign here are the same? If you remember, it's going to end up looking like an infinite solutions problem. So it means no matter what I put in for y, I'm going to end up having a true statement here. In example number 3, I'm going to go ahead and drop a line down. 2y versus 3y, so I'm going to subtract the 2y. And we're going to be left with negative 4 is equal to y minus 5. I'm going to add 5 on both sides, and I get 1 equals y. don't freak out anymore. This is fine. This is what we've been seeing all this entire chapter. So this one, we don't even really have to label it. It just has one solution. Y can only be 1. That's the only thing that will make this equation true. I'm going to have you go ahead, take a look at example number 4. See if it can be solved and have one solution, or do you result in an untrue statement, so it's no solution, or do you result in a true statement, which would mean it's infinite solutions. So distributing, I get 3q minus 15, and I get 2q plus 10. So I'm going to subtract the 2q. That gives me q minus 15 is equal to 10. So I'm going to add 15 on both sides, and that'll give me q equals 25. So this is, in fact, a one solution situation. Take a look at example number 5. Over here, you do have to distribute, but you're really just distributing a negative, so be careful about that. See what happens here, and if it's a one solution, type in your answer. If it's infinite or no solution, you want to type that in for your answer. Distributing, I get 2a minus 8. Over here, I have the 4a out front. Distributing my negative, I get negative 2a minus 4. Combine my like terms, that's going to give me 2a minus 4. And over here, I still have 2a minus 8. Notice the 2a's are going to actually disappear here. And we're going to be left with negative 8 equals negative 4. That is not true. So this one is, in fact, a no solution. And on a test or a quiz, you would want to write out all this work, demonstrate that there is an untrue answer here, and then your final answer would actually be to write the words no solution. Go ahead, take a look at example number 6. It looks like on the right side, you're going to be distributing. Find out, do you have one solution? If so, tell me what y equals. Is it infinite solutions or no solutions? So here we have the 5y plus 2. Distributing our 1/2, we get 5y plus 2. Did you notice right away they're the same thing on both sides? I could keep going if I wanted to and subtract away that 5y, which would leave me at 2 equals 2, which is a true statement in both cases. So this tells me that this one has infinite solutions. And that's it for infinite solutions versus one solution, which is what we've been seeing for the whole chapter, versus no solutions.